Hello everyone, welcome back to our PySpark series. Today we're diving into one of the foundational components of PySpark SparkSession. If you're working with PySpark, you've probably seen SparkSession come up frequently. But do you really understand what SparkSession is, why it's so essential, and how it powers your data processing tasks in Spark? In this video, we'll explore everything you need to know about SparkSession from its role as the gateway to Spark's functionality to how it helps you manage resources, execute SQL queries, and configure settings for your applications. By the end, you'll have a clear understanding of how to create and use Spark Session effectively, setting you up for success in your PySpark projects. Introduction. In PySpark, a Spark session serves as the main entry point to interact with Spark's powerful data processing capabilities. It provides a single unified environment that manages resources, configurations, and settings for your Spark application. Through Spark session, you can create data frames, perform SQL queries, and read data from various sources such as CSVs, VHSON, or Parquet files. Additionally, Spark Session enables you to configure settings that impact how Spark executes your code, such as memory allocations and parallelism. This centralized access point simplifies and streamlines working with Spark, making it easier for users to manage large-scale data processing tasks within a consistent and cohesive framework. Why Spark Session is important? Spark Session is a critical component in PySpark because it provides a unified entry point to Spark's functionality. Before Spark Session, users had to rely on separate contexts like skew context, high context, and Spark context to perform different operations. Now, Spark Session combines these into a single access point, simplifying Spark's interface and making it easier to work with. Another key advantage of SparkSession is its support for DataFrame and SQL operations. SparkSession enables users to create data frames and perform SQL queries seamlessly, whether working with data from CSV, JSON, Parquet, or other formats. This flexibility allows users to interact with data across a variety of storage options, making SparkSession highly adaptable to different data sources. Additionally, session configuration through Spark Session lets users set and retrieve Spark configurations at the session level. This includes parameters like memory settings, shuffle partitions, and other optimizations that directly impact performance. Such granular control at the session level is invaluable for tailoring Spark's behavior to the specific needs of a job. Finally, Spark Session manages resource allocation by interacting with Spark's cluster manager, executors, and other components required for distributed computing. This capability ensures that Spark Session can handle the resources needed for large-scale data processing and distributed workloads, making it a foundational tool for working efficiently in PySpark. How to create a Spark session? In this example, we begin by importing the Spark session class from PySpark.sql. To create a Spark session, we use the Spark session.builder pattern, which initializes the session. The app name method sets a name for our Spark application, in this case, my Spark application, which helps identify the job in the Spark interface and logs. The getOcreate method then completes the setup by either creating a new Spark session or returning an existing one if a session has already been initialized in the environment. This approach makes it simple to start a Spark application, providing us with a unified entry point for managing data processing, SQL operations, and resource configurations within the PySpark environment. Spark session configuration options. In this example, we are creating a Spark session with specific configurations for optimized performance. We start with Spark session.builder to initialize the session, followed by app name, where we define the name of our Spark application as my Spark application. Setting an application name is helpful for tracking and identifying jobs in the Spark VIN logs. Next, we use the config method to apply custom settings. The first configuration spark.sql.shuffle.partitions is set to 50, which controls the number of partitions for shuffle operations. Adjusting this value can significantly impact performance by optimizing parallelism during data shuffles. The second configuration spark.executor.memory is set to 2G, which allocates 2 gigabytes of memory to each Spark executor. This setting allows us to control the memory resources available for distributed tasks, balancing efficiency with memory constraints. Finally, get.create completes the setup by either creating a new Spark session or returning an existing one if already initialized, ensuring that our application runs with the specified configurations for efficient processing and resource management. Example usage of Spark session. In this example, we start by creating a data frame in PySpark. First, we define a sample dataset consisting of names and salaries, where each entry is a tuple. Using the createDataFrame method from our SparkSession object, we convert this data into a data frame specifying column names, name, and salary. Next, we display the contents of the data frame using the show method, which provides a quick way to view the data in tabular format directly in the console. Following this, we take advantage of SparkSession's SQL capabilities. We create a temporary view of the data frame using createReplaceTempView and assign it the name employees. This allows us to query the data frame as if it were a SQL table. We then use the SQL method to execute an SQL query, selecting employees with a salary greater than 4,500. The results of the query are stored in the result data frame, which we display using result.show. This code demonstrates how SparkSession enables easy integration between data frames and SQL queries, making it possible to perform complex data operations and queries seamlessly within PySpark. Common methods in SparkSession. SparkSession in PySpark offers a range of powerful methods that streamline data handling, transformations, and analysis. One such method is createDataFrame, which converts a list or an RDDD resilient distributed dataset into a data frame. This conversion is essential for taking raw data and shaping it into a structured format that can be processed with data frame operations and SQL queries. The RAID interface is another key feature of SparkSession, providing seamless access to data stored in various formats, including CSV, JSON, and Parquet. By using RAID, users can easily load data from different sources into data frames, making SparkSession highly adaptable for diverse data sources. Another widely used method is SQL, which runs SQL queries directly on data frames that are registered as temporary views. This feature is incredibly useful for users familiar with SQL, as it allows them to leverage SQL syntax to interact with data frames and execute complex queries on the data with minimal effort. Finally, udf.register enables users to register a user-defined function UDF for use within SQL queries. This method is particularly valuable for applying custom functions to data that may not be supported by built-in functions, allowing greater flexibility in processing and transforming data within SQL operations. Together, these methods make SparkSession a powerful tool for data manipulation, transformation, and analysis in PySpark. And that's SparkSession in PySpark. We've seen how it acts as the entry point for working with data frames and how it manages settings for your Spark applications. Understanding SparkSession is fundamental for working efficiently with PySpark. If you found this video helpful, please give it a thumbs up, subscribe for more PySpark content, and hit the notification bell to stay updated on our latest videos. Thanks for watching and see you in the next one.